I want to talk to you about drought stress. Many of us understand that climate predictions suggest that in many parts of the world where food is now grown routinely, the climate is predicted to get hotter and drier, and the vapor pressure deficit of the air is predicted to increase, and this will drive transpiration, evapotranspiration harder, and all of these things, combinations of these things, will cause big problems potentially for farmers. So we need to think about ways of increasing productivity, but doing so while we produce more crop per drop of water that we use. Now the targets, I think, for us are components of drought tolerance, plants which grow and survive well at low water potential, fairly hard to find. Perhaps more importantly, drought avoidance mechanisms, where plants scavenge more effectively for water in the soil. They cover the ground quickly to reduce wasteful water loss from bare soil, and most importantly perhaps, they regulate gas exchange by particular types of stomatal behavior. So there are some very specific traits, things like root hydraulic architecture, hydrotropism of roots, shoot properties like redistribution of assimilates in the shoots, and perhaps stay green biology. There are some very, very exciting things where we have new information which we can potentially exploit. So I'm arguing for specific traits. Importantly, I think we need to look for these in screens where we actually do subject the plants to controlled drought stress. Traditionally, screening for high yields is done under yield potential conditions, and the classical postulate is that these plants that we select will also do well under stress. And of course, historically, this has turned out to be the case. It's been a very successful approach. But I would argue that we're missing a lot here, and we need to look more in a more detailed way at what is actually going on when the plants are mildly stressed. There's some biology there for us. So specific traits, I think equally important probably is to define where it is that we're going to use these things. We know that not all biology works under all circumstances. Single traits can be highly beneficial under some circumstances, and when drought is slightly different or there isn't any drought, those traits can be damaging to the plant. So we need to understand the idea of what's going to work where, a combination of specific traits with specific environments. I guess finally, I would argue that there is this really good opportunity for breeders and agronomists to work together. My own interest is in plant growth regulators, a very exciting understanding of a lot of the sort of biology that we've talked about, the regulation of much of this involving abscisic acid, auxins, cytokinins. We can manipulate those things through agronomy. Genetics can also contribute a lot by delivering particularly advantageous genotypes. Exciting times.